we got more science experiments going on right
Sarah,
now.
are you ready to glow in the dark?
I think I sure am. You really are the part today, a mad scientist.
Oh, yes. Jeff Manthorpe. Carleton University Chemistry Department's Jeff Manthorpe, the professor, is here. All right, so we're going to do some glow-in-the-dark stuff here?
That's right, and I wanted to do some stuff today that you can maybe do at home.
Okay.
So one of the things that is really cool, and you may have noticed this if you were out at a bar and perhaps having a gin and tonic, if we get the lights turned down a little bit, you can see this is actually just tonic water.
Yeah.
Right? And
there's an agent in tonic water that does this?
That's right. So the tonic water is actually, it was originally used as a tonic for malaria.
Ah.
And the active ingredient in that tonic is quinine. You might have heard it pronounced quinine.
Okay.
And it is actually what's fluorescing here. And
look at that.
Believe it or not, it is actually still used today as a drug for malaria treatment.
Oh, wow.
Really?
It's not usually the drug of the first drug of choice,
but it's readily available, right?
It is, and it's typically from the bark of a tree.
Wow.
And it's often used to treat multi-drug resistant malaria. So if you've got a really bad case of malaria, this is what they'll give you.
So why is it not the first choice? Are there
some of the
effects?
Well, not really, because otherwise we wouldn't put it in our tonic water, right?
Yeah, I'm wondering.
Well, yeah, it's the first rule of toxicology is that the poison is in the dose. So the dose makes the poison. So you can have too much of anything, right?
So
you
too
go
much
home
too many gin and tonics.
Yeah.
Too many gin and tonics, sure. But if you go home and drink 20 liters of water, you're not going to feel very good.
No, you're not. Right? In fact, you're going to die.
Yes.
Yeah.
Yeah.
From hyperhidrosis, right?
Yeah.
All right then.
Yeah.
Don't do that. Just don't do it.
Yeah.
Okay, so let's. You know what? Should we keep the lights down? This is all glow in the dark.
This is
We're
all
going to keep the lights
glow-in-the-dark
down the
stuff.
whole time. Besides, I like how the black light has effect on my dome.
Well,
look at this.
what you can actually see sometimes is that it does actually have an effect on makeup.
Yes.
Right? So if we actually do this.
Oh. Look at that.
And
that's cool.
You can do your own CSI on your shirt.
Yeah, there's some of those when you walk into nightclubs, you see some people who need to be doing some, some lint removal.
Yes.
All right, what's up next? So there's stuff we can do with quinine, right?
That's right. So what you can do with tonic water is you can use it to cook things, believe it or not.
Okay.
And you can have some fun. So what if we made some of our own glow-in-the-dark spaghetti?
Really?
So here's some regular spaghetti.
Okay.
That I just made last night, cooking in water. And now in my other container here.
Looks the exact same.
Looks exactly the same. And you can see that this actually glows a bit because what's happened is it's absorbed some of the quinine from water.
Isn't that amazing?
Along the bottom.
Yeah. Right on the black light there. That is so cool.
Yeah.
So you could have a little spooky dinner.
Yeah, for sure. Yeah, I can just.
And nothing's wrong with it. It's edible, of course. It's just tonic water.
I hope it's edible.
I hope it's good.
They're eating it. I know that Leanne mentioned this earlier, but it's really too bad that more examples like this aren't incorporated into the typical science class because you're learning and you're having fun, right?
Yeah.
Totally.
Yeah, you
Exactly.
can eat spaghetti that tastes like tonic water.
And there are several things to learn from this, the reactions, and whenever you see, earlier we saw you have two reactions within one motion almost. But there's a lot of chemistry happening in those moments, right?
Yeah, and some of these reactions, some of these demonstrations have been known for decades, and we still don't completely understand how they work.
Is that right? Isn't that interesting?
So,
okay, Jeff, next up, Professor, perhaps we should you have some sort of glowing fluid over there.
Glowing beacon over here.
Yeah, so this I have right here. You can see it's just a colored liquid, okay? And what we're going to do is we're going to make some slime.
Ooh, okay.
I like it.
Yeah, and so the active ingredients we use here are polyvinyl alcohol that's dissolved in water, and I think a lot of people here are actually wearing some polyvinyl alcohol today because it's often used in cosmetics.
Ah.
I might be covered in polyvinyl alcohol.
And
is that green food coloring?
This is just green food coloring because, I mean, it's slime. We got to make it green, right?
Of course.
Right? So we'll just put in a couple drops here.
The slime drops.
5 drops.
Give it a bit of a stir.
Ooh, slime.
Okay, and now the other ingredient here is borax. So you can actually make some slime at home that's not transparent like this, but is more opaque by taking Elmer's wood glue and mixing it 1-to-1 with water.
Okay.
Okay, and then you use some borax, which is often used to enhance the cleaning power of your laundry detergent, and you make dissolve as much of that in water as you can.
Okay.
And then you combine them.
Oh, it's going. I saw it go gelatinous almost immediately.
Yeah, look at that. Okay, and now I'm going to add a little bit more.
Yes, get it really thick and slimy. So, you know, if I wanted to, I could throw it at someone.
If that happens, I can't tell you enough how much there will be a revenge.
Oh, doesn't that sound?
Oh, that sounds great.
That sounds
Besides,
like a
I don't own this costume.
challenge.
Now
Okay.
watch what happens if we turn down the lights.
Just one more time as we head to break.
Ooh,
Look
it
at
looks
that!
toxic.
That is so cool.
Now, can you touch it?
Oh, sure. There you go.
So I could touch it.
There you go.
It feels like
This is pretty much the same stuff you get in the toy store.
Oh, really? Okay.
Yeah, they often put a little something else in it to prevent it from growing things.
Oh, that's nice. Yeah. Preservatives, you mean?
Yes.
Okay.
Yeah.
Very cool.
oh, because it okay.
Professor Jeff Manthorpe from Carleton University, the chemistry department. Always so good to see you on a Halloween day like this.